A uniform block of mass 10 kilograms is released at rest from the top of an incline with a length of 10 meters and an inclination of 30 degrees and slides to the bottom. The coefficients of static and kinetic friction are both 0.1. How much energy is dissipated due to friction? So I'm going to start by drawing a diagram of what this might look like. It's horrible. So I'm going to draw a triangle. I'm going to try to draw a triangle here. Okay, that's good enough. Basically, it looks something like this. The incline is going to look something like this. Its inclination is 30 degrees. And we're going to have the block here, which I'm going to represent as a point. Now we can draw a diagram for this point. Free body diagram. Okay. So there's going to be gravity, which points straight down. And the normal force, which is perpendicular to the surface of the incline. And there's also going to be the force of kinetic friction. Since the block is sliding down to the bottom, the force is going to be the kinetic friction that's opposing its motion. So we can decompose the force of gravity into a parallel component and a perpendicular component like this, where this is the angle theta, the incline of the angle of the incline. And so from using trigonometry, this component will be mg times the cosine of theta. And this component will be mg times the sine of theta. And now we can start writing our equations. And we actually only need to write the one for the direction perpendicular to the surface of the incline. So we have the normal force. And opposing the normal force, we have the component of gravity perpendicular to the surface. And that's going to be equal to 0, since the block is not accelerating in the direction perpendicular to the incline. So from that, the normal force is going to be equal to mg cosine theta. And the force of kinetic friction is given by the coefficient of kinetic friction times the normal force. And we found the normal force to be this quantity here. So we can just plug that in to get the coefficient of kinetic friction. Times mg cosine theta. And that gives the frictional force. Now we need to find the energy that is dissipated to friction. So basically we're trying to figure out the work done by the friction. So the work done by friction is going to be the negative of the force of kinetic friction times the distance, which in this case is the length of the ramp. And this negative is here because it's opposing the direction of motion. So this is going to be equal to negative of the coefficient of kinetic friction times mg cosine theta times L. And now we just plug everything in. So this is, the coefficient is 0.1. The mass is 10 kilograms. The gravitational acceleration is 9.8 meters per second squared, times the cosine of the angle, which is 30 degrees, times the length of the incline, which is also 10 meters. And this should give us about 84.9 joules. So the frictional force dissipates 84.9 joules of energy. And that is how you would solve this problem here.